So this team was called, oddly enough, SpaceBBQ.
Yeah.
SpaceBBQ. And SpaceBBQ, also influenced by a movie, Armageddon, sorry, they're doing asteroid mining by SpaceBBQ. So, asteroid mining, give it up.
Technical difficulties. Yeah, it's kind of lagging opening a slideshow.
It's not an image or something.
Yeah, I pressed the slideshow.
That's what I got.
Oh, I don't have this.
Oh, all right. Okay. Hey guys, my team and I, we were looking at asteroid mining, and we were trying to come up with innovative solutions to make it more possible, make it easier for it to happen, and make it more effective. And we came up with SpaceBBQ, which we'll just get into. But first, our problem that we were looking at was drilling. We're trying to come up with a better drilling system than what's available now. But the drills available now aren't too great. They need a lot of maintenance. The drill parts get damaged, you need to replace them. And when you're dealing with asteroids, which are millions of kilometers away, you can't send someone to replace a drill bit. So we need something more effective, more efficient, something that'll work every time. And this is our solution. We're using tungsten as a material to heat up. Basically, these are rods made out of stuff. And it will heat up to about 3,000 degrees centigrade, up to the point where it will cut through asteroid like butter. And then it's got a tube that it will collect in. This is a 3D model that we did of the system. This is the drill bit in here. This is an actual entire capsule with land. We've got the size of this is 5 meters by 10 meters by 10 meters. There's enough room there to have billions of dollars worth of material. This is another view. That's the drill bit. It will fit down and basically go into the asteroid. Yeah, thanks. And this is the actual drill bit up here. So as you can see from better than my other diagram. So these bits will heat up and it will slowly go into an asteroid, and then basically melt it. It will go. The asteroid bits will go in, and yeah, and that's how we store it. And we did come up with an automation system as well to try to automate our idea and make it practical. So we made a program just to test it, and this is the velocity output. For different materials, you have to have different timings for landing, as we need to heat it up as it's landing. Next. So why is this problem big? Why did we choose this problem? Well, humanity itself, over the last 200 years, was tripled. By 2050, there's meant to be 10 billion people on this planet. Which is crazy. We can't sustain that. So we need more minerals, and we somewhat might have to get off this planet one day, in terms of if we get hit by an asteroid, or if we just screw up the planet a lot more. So by doing asteroid mining, we're opening up the gateways of basically going into the solar system and humanity spreading out. So that's why we thought this problem was big and why we wanted to look into it. Next. Yeah. So we did a lot of analysis. We did a big material analysis about all the different elements we could mine and all that. We also did a big power analysis to see if it was feasible, if we could get enough power, and we worked out it was possible. And we worked out it was profitable. This 16.3 billion, that's just off platinum, and that's the material, how much we can get from one tube, which is just, we can get a lot more than one tube. But yeah, so it's profitable and it's doable from everything we've calculated so far. Yep. So who are we? We're a team of engineers. So we've got physicists, biomedical, we've got electrical, mechanical, and we all came together, including IT, to work on this project from all different angles, and this is what we came up with. Next. And what do we want to do? We want to explore this further, and we want to do real experiments in labs to push the material boundaries and like prove it basically. Yeah.
I guess I'll have to start this one. You want to heat stuff up to 3,000 degrees Kelvin.
That's it's 3,200.
Around like 1,600.
Yeah, so 3,200 is the limit for that melting point.
Let me get the question
Yeah, sorry.
out. 3,000 degrees. There's two challenges. I don't want to call them problems because I understand this isn't something you could just code up and whack on an iPad. So I got to judge it a little differently on feasibility. 3,000 degrees, but you only need 44 watts to do that?
Yeah.
It's the current.
It's the current. It comes down to, so the current's pretty big. The current, do you want to bring up the, we can't. We have all these slides because we did technical stuff.
one.
But basically the current's
Oh, wait,
pretty big. We need capacitors, supercapacitors to produce the current. And you can do that by having supercapacitors in,
So
right.
you charge one,
Yeah.
you discharge one into the drill, and then once someone's finished discharging, you've got the other one charged up to use.
If you guys got other questions, I could keep going with these guys all day.
Is it feasible?
Well, look, I mean, my view is, I think 44 watts. Did you do any
that was proper technical.
Technical math.
That's the actual wattage of
Yeah.
heating up the stuff. You do
Yeah.
need more power for the capacitors before it. That wasn't the full analysis of the system, but it's very much doable from what we can see.
It's feasible under certain conditions, and without wasting everyone's time, I'm happy to talk to you guys afterwards. I think it's an interesting idea. It deserves exploration. I think it certainly deserves that. There's a lot you got to look into in terms of surface tension, thermal analysis. I don't think the thermal analysis is deep enough to say, yeah, it's a go, or no, it's not.
Yeah.
I have seen really good space teams launch, spend a lot of money on stuff. They get up into space because you the same technique to release solar panels in small satellites. So you get a burn wire and you heat it up until it melts, boom, off it goes. If you are successful, it's great, but you're in a vacuum and it's quite cold in space, so you might want to take a look at that one. It looks a little wild, but we'll be talking about it later.
Yeah.
Awesome. Thank you. I think it was Ben Affleck who asked Michael Bay. Has anyone who's seen Armageddon here? Right? Yeah. It's absolute crap, but I love that movie, right? And basically, Ben Affleck goes, after they've written the script and everything, because Michael Bay doesn't really write scripts, as you know, he literally asked Michael Bay, he goes, wouldn't it make more sense to train astronauts in mining and drilling as opposed to actually sending miners up there? And his response was simply, shut up. Anyway, okay, so